Okay, so in this little video, what I want to do is show you how to use one of these cool 4x4 keypads. They're super easy to interface in the basic means. And I'm going to start off by hooking it up to the Teensy, which is remarkably easy. And then we'll go ahead and hook it up to the Uno and then one of these Nano boards so we can play with it a little bit. So that being said, let's just go ahead and get started. The first thing you're going to have to do is get the library. And there's a couple of libraries, actually lots of libraries out there for keypads. Probably the best way to do it is just go to Include Library, and then from here go to Manage Libraries. And once this actually loads, it might take a few moments because it's going to go ahead and check to see all the latest libraries and everything else that are out there. So you can see mine's taking a little bit of time to upload the latest libraries. Then what you want to do is just type in KeyPad, and it should, oops, there we go, it should automatically adjust. And the one that I like a lot, it's been around for a long time, it's often referenced, is the one, let's see, we'll scroll down here a little bit. I've already got it installed, so I don't want to do it again. Here it is, by Mark Stanley and Alexander Brevig. Okay, so go ahead and you should have a little thing here that says to install. Install this one. I've already installed it, so I'm not going to do it again. In fact, I don't even think I can. And once you've installed it, what should happen is you're going to get this choice of examples. So I'm going to go to examples. Probably be down at the bottom, keypad. And this is probably just a little bit off your screen. Maybe you can see the very bottom of it here. I'm on keypad. And the one that I want to go to is custom keypad. I think that's the easiest to work with this 4x4. Okay. So here I've got my custom keypad demo example. And you can see we've got an array right here with rows and columns. And it's actually hooked up to pins 0 through 7, which is super easy to hook up with on the Teensy with the Patton Robotics motherboard. So I'm just going to go ahead and plug this guy in, just right off the bat. You know, I'm just going to go ahead and hook it up. And now notice on the Patton's Robotics motherboard, the very first pin is actually a ground pin, so do not plug it into the black pin. We just want to hook it up to the very first yellow and then snap it in like so. Okay? And we should be ready to go, just like that. Okay, this guy is plugged in, and I don't have to do anything. I've got a Teensy 3.2 selected, the port selected. I'm just going to go ahead and upload it, and let's see what happens. Alright, so let's open a serial port. And get this down here a little bit. Oops, hold on a second. Sorry about that. Oh, I may not be able to make that any smaller, so let's just deal with it. So, notice what happens here. If I click on a 1, I get an F. 2, 3. It looks like all the columns and rows are working, but clearly this is not the right selection. So, 1 gives me F, 2 gives me E, 3 gives me D. Okay? Now we have several choices here to correct it. You can see that we can manipulate the pins that are hooked up to columns and rows. But honestly, I think it's just as easy right now to look at what we were dealing with. You see we got an F, E, D, and C. And if I click this again, you'll see that that's going to be an, oh, I can't see it. Hold on a second. My 1 is an F. My 2 is an E. My 3 is a D. My A is a C. Well, okay, that's pretty easy to switch around. Why don't I just make this, for example, a 1, a 2, a 3, and we can see that the next one over here is A. Okay. In fact, if I upload this, you'll see that it already, the first column is pretty much corrected, and you can probably figure out what to do with the next one. So now if I touch a 1, it's a 1. If I touch a 2, it's a 2. 3, A. So now we have 4 is actually a B, and 5 is a A, and 6 is a 9. So clearly what we have to do here is we have to switch this around. So this is going to be a 4, a 5, a 6. This is a B. This is going to be 7. This is going to be 8. This is going to be 9. Again, I'm just kind of running off of my keyboard here because you can see what's actually happening is it's actually out like this. So if you hold it, right, this is my A, this is my B, this is my C, there's my A, B, B, C, 7, 8, 9, 7, 8, 9. So that makes this is going to be a star, 0 pound. And again, I could have done this I could have sat there and sort of thought about which column and which pin and whatever else. But honestly, this works pretty darn well. And I really don't have to think at all. So now we should have this hooked up. And if I plug it in and enter it, you can see 4, 5, 6, 8, 9 pound. Okay. And boom, it works perfectly. All right. So there you go. That's the first example. And it works effortlessly. You can just plug it in and you're ready to go. Mind you that if you really wanted to, you can set these pins to anything you want. If you wanted it on this side, you could have chose pins 23, 22, 21 on down. I could have started at 13, 14, 15. You can do whatever you want to. This ribbon cable looks like it's going to keep you limited. If you want to plug it straight in, you're going to have 8 pins in quick succession. And we'll talk about that in just a moment. So let me pause it and get it set up for the Arduino Uno. We'll be right back. Okay, so here I have it hooked up to an Uno. You can see that I'm using some male-to-male jumpers. I found it a little uncomfortable when I was plugging it in to jam them all in like I did here. It was just kind of wadding up. So what I did is I went to every other pin. So I went 0, 2, 4, 6, 8, 10, 12, and then 13. And on code, that just means you have to actually, account for it. So 0, 2, 4, 6, 8, 10, 12, 13. I loaded it up. And when I did, in fact, I've got a response like this. So you can see that if I type a 1, let me move this key, let me move this over a little bit so you can actually see it. If I type a 1, I get a D. If I type a 2, I get a C. If I type a 3, I get a B and an A. So basically what that means is that we have to rearrange all of these, D, C, B, A. So my D becomes a 1. So you can see, choosing the way that I did it, I really kind of have to do this. Okay? And I imagine, I don't know for sure, but I'm going to imagine that's 4. And, oh, you can't see that. I'm so sorry. Hold on a second. Let me drag this on the screen. So this was my DCBA. So now what I'm doing is I'm changing all these values in accordance to the way that I strike it. So, and then if I look here, actually I should load this and see how I'm doing, because I might have screwed this up. Let's take a quick look. We're only 8 minutes into the video, so we've got plenty of time. So if I move this aside, pull this down to right here so we can see everything, and pull this up. Alright, when I touch a 1, I get a 1. That's good. 2, 3, A. That's perfect. 4 is good. 5 is good. 6 is good. 7. Oh, that's what I screwed up. 7 is actually B. Okay, so where I have a B. So this is going to be a B right here. And this is going to be, I bet this is all going to be A, B, C, D. And 4, 5, 6. So that makes this is probably going to be a 7, an 8, and a 9. And that makes this is going to be a 0. And then we're going to have next to the, between the 0 and the D, I should have the pound. And this is going to be the star. So let's load it up, see if I got this right. All right, looks like it's done. So let's see how we're doing. So D is D star. Oh, I'm sorry, the hashtag 0 pound or star. C. Yep. Okay, so we got it figured out. So once again, hooking it up to the Uno is really pretty easy. Just plug it in and you're ready to go. So now I'm just going to hook it up to one of these guys, which won't be that much different. In fact, it'll almost be identical. And but actually, there's an important point I actually want to show you. The temptation might be, maybe I'll unplug this and set it aside. So I have another one of these. And ultimately, it is pretty much the same. But I do want to point this out. The temptation might be to say, oh, look at that. I've got, for example, 8 pins in succession. I could just plug it in like this, and I'm good to go. I could just declare it as pins A0 through A7. Well, that's actually sadly not the case, because it turns out that on a Nano, okay, normally analog pins are both fully analog and digital with the ability to actually do a pin mode input, so you can pull up, so you can turn on a pull-up resistor. Notice this guy doesn't have a power and ground. All of its functions are set by actually charging the pin, okay? And if we can't charge the pin, well, we can't determine whether or not it's been set to ground or not. And it turns out that the last 2 pins, 6 and 7, of the analog port on a Nano do not have input pull-up resistors that you can enable. So therefore, you simply can't do what I've done right here. You're going to have to do it like you did on the Uno and then take advantage of these ports. Now, if I had a set of pins that were, say, double-headed male, I could slide that in and then plug it into these 8, but I don't have that. Okay, so I'm going to have to use the same set of header pins like I did right here, jumper pins, and I'll set it up and then we'll see it go. But apart from that, it's pretty straightforward. Just sadly, you can't just plug it in like this on these 8 pins and expect it to work. It just won't. Okay, so give me a moment and I'll set it up. Okay, and here you can see I've hooked it up exactly like I did with the Uno. I skipped every other pins, so I'm in 0, 2, 4, all the even pins all the way up to pin 12, and then I went into 13, just straight in a row. And because of that, you would expect it to behave exactly the same, and sure enough, it does. So here's that code showing you that I did do 0, 2, 4, 6, 8 all the way up. And then, of course, this is the array as it's defined. And when I go here, you can see that, for example, if I type a 1, I get a 1. If I type a 5, I get a 5. If I type a D, I get a D. So everything works exactly as you would expect with this particular arrangement of array in this particular pin configuration. And by the way, this is actually a Nano with a 168 base chip. You can see how small it is, and it works just fantastic. So hopefully this is useful, and I will see you all again really soon.